is going to discuss about electrostatistics. It is unit 2 for your electromagnetic theory. In electronics, first we are going to discuss about electric potential. What do you mean by electric potential? It is defined as the amount of work energy needed to move a unit electric charge from one point to another point. It is given in terms of electric field as V equal to minus integral of E dot dl. There infinity can be chosen as infinity to R. Next, discuss about the electric potential. Here, E equal to, already we have know from Coulomb's law, E equal to Q by 4 pi epsilon naught R square into its unit vector. Here we need to get the electric potential. For electric potential, V equal to minus integral E dot dl. For minus integral E dot dl, here instead of E, we have substitute the values of E, Q by 4 pi epsilon naught R square AR into the distance can be chosen as dr since it is lies along the R vector. So dr, its unit vector is AR. AR dot AR becomes 1, so you can leave the unit vector. And if you integrate this value, you got the answer as 1 by RB minus 1 by RA, since its limit is RA to RB. From this, we have obtained the electric potential V equal to Q by 4 pi epsilon naught R. Here it is the problem. Here we are considering two charges minus 4 microcoulomb and 5 microcoulomb are located at two different points 2 comma 1 minus 1 comma 3 and 0 comma 4 comma minus 2. Here we need to calculate the potential at the point 1 comma 0 comma 1. Let us start. First you need to write the given data where Q1 value is minus 4 microcoulomb and Q2 is 5 microcoulomb. We know the formula for V. That means potential V equal to Q1 by 4 pi epsilon naught R minus R1 plus Q2 by 4 pi epsilon naught R minus R2 plus CO. It is the constant. Here assume the constant as CO as 0. Okay. Integrating constant is CO. No need to substitute in your problem. First you need to calculate the distance between R minus R1 and R minus R2. That can be obtained by subtracting the point at R. Here the R is 1 comma 0 comma 1 minus R1 is 2 comma minus 1 comma 3. Similarly R minus R2 means 1 comma 0 comma 1 minus 0 comma 4 comma minus 2. Okay. You have the values as root 6 and root 26. Now you substitute the values of R minus R1, R minus R2 and Q1, Q2. You obtain the value of potential as 10 power minus 6 divided by 4 pi into 10 power minus 9 and 36 pi into minus 4 by root 6 plus 5 by root 26. You have the value as minus 5.872. Here this is direct substitution. Okay. Directly we are substituting the values of charges and the distance vector and you obtain the value of required potential. Thank you. Let us discuss about the electrostatic energy and energy density. Okay. To determine the energy, first we need to know about the work required to assemble the charges. To determine the energy density, first let us consider three different charges Q1, Q2 and Q3, and the amount of work done in bringing Q1 is 0 but because it is the initial charge, and Q2 it have some work done, that is given as W1 equal to Q2 into V2 Similarly Q3 equal to Q3 into V31. That is the work done by the charges. To determine the value of energy density, first we need to derive the value of work done to move a charge, point charge from one distance to another distance. Okay. Here you are going to consider one diagram, that is choosing 3 points P1, P2, P3 and the Q1, Q2, Q3 are the charges. It travel from point 1 P1 to infinity, similarly P2 to infinity and P3 to infinity. Okay. For this, the work done by the charges, work done by three charges from moving from point P1 to infinity can be obtained as W1 plus W2 plus W3, where work done for initial charge Q1 is 0 plus, and Q2 is Q2 into V21 plus Q3 is Q3 into V31 plus V32. Similarly, WE in terms from starting from Q3, Q2, Q1, you got W3 plus W2 plus W1. Here the initial work done on Q3 is 0 plus Q2 plus V23 plus Q1 into V12 plus V13. To determine the total work done, we need to add both. Okay, W2 WE equal to, you got like this, Q1 V1 plus Q2 V2 plus Q3 V3. We need the work done value. Therefore, total work done by the average work done by the charges WE equal to half into Q1 V1 plus Q2 V2 plus Q3 V3. Therefore, for a we have considered 3-point judges. For 3-point judges, we have the work done as half Q1 into V1. So, the work done is equal to half into Q1 V1 or half into QV. That is the work done by along the charges. If you consider a volume charge, you need to integrate it. So, okay. If you consider a volume charge with the volume charge density rho V, therefore, the work done along the volume charge WE is equal to half into integral rho V into V into dV. V is the potential and rho V dV is the charge along the volume surface, volume, okay, right. Here rho V can be considered as del dot D, therefore substitute the value of rho V as del dot D, you got half into integral V into volume integral of del dot D into V into dV. Del dot A into V can be taken as del dot V A minus A dot del V. So substitute these values instead of del dot D, you can rearrange the equation as WE equal to half into integral V del dot Vd into dV minus half into integral V d dot del V into dV. Again, simplifying this equation, you got half into volume integral of d dot E into dV. D means epsilon E. Substitute the value of dE, you got half into epsilon naught E square into dV. That is the work done. Similarly, the work done can be taken. Therefore, the energy density along the work done can be obtained as work done per potential. How much potential you have applied to move a charge from one point to another point is the work done. Therefore, energy density is work done per volume. Work done per unit voltage. That means work done per potential. That is taken as work done per unit volume. We have considered for volume. So, work done per unit volume is the energy density. Therefore, WE is equal to half into d dot E, that is half into epsilon naught E square, that is d square by 2 epsilon naught. Any things you are right. This is the energy density, value of energy density. See one problem along energy density. Here they have given 3-point charges located at each point 0, 0, 0, 0, 1 and 1, 0, 0. Here we need to calculate the energy in the system. Already we have know the work done by the point charges W is equal to W1 plus W2 plus W3. Therefore, W1 is 0 already. W2 from Q2 V21 and Q3 V31 plus V32. You substitute the values here. Q2 into Q1 divided by 4 pi epsilon naught 0, 0, 1 minus 0, 0 plus Q3 by 4 pi epsilon naught Q1 divided by 1, 0, 0 minus 0, 0 plus Q2 divided by 1, 0, 0 minus 0, 0, 1. Yeah, now you simplifying these and substituting the values of Q minus 1, 4 and 3 in these equations, you got the value as 13.37 nanojoule. Thank you, students.